Saxon Algebra 1, Lesson 57. Greetings, my students. Welcome to another glorious lesson. Today, we're going to deal with one of those situations where you just think, man, that's kind of tricky and it seems too complicated. But I'll tell you the secrets of it and it'll be fine. The problem, let's just look at an example. That's the easiest way to explain it. There are 3 examples to this lesson. And the first one, I'm going to show you what it is not, okay? We're used to problems that would look like this, right? Everything is being multiplied, and we've got some negative exponents. Now, we've said that negative exponents are neither right nor wrong. They don't need to be simplified. But if we wanted to rewrite this with positive exponents only, we would write A, and then we would create a denominator and we'd bump both of these to the denominator, right? And that would be our answer. But the problem we're going to address is not exactly this. It's this. This is what's different. What happens when we put a plus sign in the middle of a problem with negative exponents? Adding with negative exponents. See, that's the topic right there. What it does is it fractures this problem into 2 terms. If you compare this one to this one, this is all one term. Here we're breaking it into 2 terms. That changes everything because the negative exponents now have to be treated separately. So the way that we simplify this instead of that way, I'm going to go down below. It would be A, and then this x goes in the bottom, plus this y goes to the bottom, and we put a 1 in as a placeholder. Okay? So these are 2 very different things. And the difference is that plus sign, it fractures one term into 2 terms and requires us to start our simplification in a very different way. Now from here, this is a fairly familiar problem and we can go on without a lot of drama. This is the part that we need to pay close attention to. Okay, so let's go on from here now. We'll get a couple more chances at doing this. Now we have 2 fractions that we're trying to add. We have to make the denominators match. We find the LCM, the least common multiple. I like to call it that because that reminds me that I multiply to create it. X times y. I'll write it over here. And now we're going to multiply. This is not an equation, it's an expression. So we have to multiply top and bottom in order to get matching denominators, and then we can smush it together. If we have an equation, we can make the denominators go away. But there's no equal sign other than the one I put in up here. So we have to go with top and bottom. So this one, y over y, x over x. Remember, this is just like any fraction work we've ever done in the history of man. And we get ay over xy plus x over xy. Oh, look, now they match. So we can mush them, and we get ay plus x over xy. We cannot do any canceling. There's a y above and below, and there's an x above and below, but they are being added. If we could factor one of them out, we could potentially cancel, but we can't factor anything out. So this, dun, 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 is our final answer. Let's try another one. Let's try 2 more. You wanna? It's gonna be fun. I think 3 is a good number because the first time you're just like, what? And the second time you're like, I kind of see. And the third time is like, okay, that actually makes a little bit of sense. That's my thought anyway. 57.2. My hand ran away from my brain. Ready? Here comes the problem. Add, and then it says write the answer with all the exponents positive. The last one said that too. Write the answer with all the exponents positive. So John's being very clear what he wants. And here's the problem. Okay, I didn't talk about this last time, but, well, no, let me say this first. There's our plus sign. That reminds us that it's not a single term, it's been broken into two terms, and we have to address each one as a separate chunk. Now, this minus 1 only relates to the y. I didn't talk about this part last time. I talked about that part last time, but I didn't talk about this. If we wanted this whole term to be raised to the minus 1, we would put parentheses around it. But if there aren't parentheses, then the exponent only relates to the base immediately before it. Okay, so it's not a to the minus 1, it's just y to the minus 1. So the a stays up top, the y bumps down, and then we add busy. Okay, now that takes care of all of the weird hard parts, right? Now we do LCM, and this is over a 1, right? Because there's no denominator, so I put it over a 1. My least common multiple will be just a plain y. So I can multiply this by y over y. And I can do this all, I can see the denominators match, so I'm going to write it as one big term right now. Oh, I forgot one piece of, I'll just leave it like this. I didn't copy one piece of the problem. I've done everything right. Let's just leave it like this. It would be a plus bzy over y. This isn't exactly like the problem in the book, but this is all correct, so I'm not going to confuse you by changing it. Okay? In this one, what was tricky was that we had to deal with a term that has no denominator, so we had to add our own in. And I also clarified this thing about how the exponent only relates to the base immediately before it, unless there are parentheses. Okay, last one, are you ready? Let's go to a fresh page. I hate to squish. Example 57.3. It is a little bit more complicated. But the same idea. John's into Z in this lesson. Remember, these are my Z's. They kind of look, if I don't make that slashy line, my Z ends up looking like a 2 really quickly. So I always put the slash there. Some people slash their 7s. That's a thing, but I slash my Z's. Okay, let me just double check to make sure I copied it right, since I did that last time. Okay, beautiful. There's our plus sign. It reminds us that we have broken this problem into two separate terms, and we have to deal with each one's exponents on its own. All right, this tells me that the a is going to go downstairs, the y is going to go downstairs, the x will stay up. So let's do that, x over. Now the a is a squared, so it still has a number when it goes down. It just burns off the minus sign. The y also goes down. That would make it y to the first power. I'm not even going to bother writing that little 1. I can put it in or take it out as I see fit, and I choose not to. Okay? Plus, and now here the z is going to go down, and again, it would be z to the first power. I'm not going to put the 1. Okay, beautiful. That looks good. Now we're ready to create an LCM. This one's going to be a little bit of a doozy, isn't it? Because none of this matches, so we'll have to, I'm going to go alphabetical. A squared y z. So again, there's no equation sign, no equal sign. There's no sign of an equation. So we multiply each fraction by its missing piece. So this one, I'll do z over z. And this one I have to be, no, I don't have to be careful. It's a squared y over a squared y. All right? Now I'm going to be able to multiply these, put the denominators with a plus sign, and I'll just write the denominator once. So it's x, z, plus, this will be a cubed y, right? Because a times a squared equals a cubed, and then there's the cute little y. And then my denominator I can write just once because they match, so they can go together. A squared y z. And I'm double checking to make sure I got it right. Yes, it's perfect. Yay. Okay, so the takeaway for this lesson is when we have a plus sign in the middle of our terms with crazy exponents, we have to treat them separately. We can't make them into one big fraction. We have to break them apart into two and then continue on adding just like we know how to do. Yay! We're done with lesson 57. Look at that, we're already into the next week, the third week after the break. This is week 16. Woo, we're making progress. Okay, thank you, good luck, goodbye.